7.4, factored form of a quadratic function. So we're going to be using our factoring skills a lot from your last review sheet that you would have completed. We need to know how to factor our quadratics in order to identify our solutions or x-intercepts algebraically without using technology. So this skill is very, very important from here on out. We want to remember that any quadratic equation can be written in the standard form, ax squared plus bx plus c equals 0, where a cannot equal 0. If this factors easily, then we can use our zero product theorem to extract the roots, so to identify what our zeros, our x-intercepts, our roots, our solutions are going to be. The zero product theorem says that if a times b equals 0, then a either equals 0 or b equals 0 or both. So for example, if x plus 5 times x minus 2 equals 0, then that means x plus 5 must equal 0 or x minus 2 must equal 0. And if that's true, x plus 5, in order to make this 0, x must equal negative 5. And if you ever want to do the math for that again, you're just subtracting 5 from both sides to solve for x. X equals negative 5. And for x minus 2, we'd add 2 to both sides. X equals 2. We can use factoring or partial factoring to help us sketch a quadratic function given in standard form once we find our intercepts. Then we can find our vertex because our axis of symmetry is going to be directly in between those two, so we can add them up and divide by 2 to identify our vertex, plug that back into our quadratic equation to identify what our y value will be at that x value of our vertex. So the first things first, again, we want to look for common factors, so we want to remember that. Number one thing is there a common factor? So example 1. Sketch the graph of y equals 2x squared plus 12x plus 10. We don't want to use our technology here, so we want to identify where would my x-intercepts be, what's my vertex, we want to solve all of that. So first thing, is there a GCF? Yes, there is. I can divide all of those terms by 2. So y equals, I'll factor out a 2. 2x squared divided by 2 is just x squared. 12x divided by 2 is 6x. 10 divided by 2 is 5. So now I'm looking for what would multiply to 5 and add to 6. X plus 5 and x plus 1. So if we're looking for our x-intercepts, that's going to be when our y value is 0. So in order for this equation to be 0, 2 can never equal 0, so that's always going to be 2. But x plus 5 could be 0, or x plus 1 could be 0. So in order to identify if x plus 5 equals 0, subtract 5 from both sides, then when x equals negative 5, that equation would be equal to 0. So that's one intercept that would make my equation 0. Or x plus 1 could equal 0, which means if x plus 1 equals 0, then x would have to equal negative 1. And that's going to be my second intercept. So I can go and plot those 2 points on my graph when x is negative 5 and x is negative 1. Negative 1, 2, 3, 4, 5. Those are my roots or my zeros. Now to find my vertex, my axis of symmetry is going to be directly in between those. So I can see right now it's going to be at 3. That's right in between. But to identify that, it's just a matter of adding up your x-intercepts and dividing by 2. So negative 5 plus negative 1 divided by 2. Negative 6 divided by 2 equals negative 3. So the x value of my vertex will be at negative 3, my equation of my axis of symmetry. So I know that that equation, that dotted line that would split my quadratic in half, is at x equals negative 3. Now we need to figure out what my y value is at that point. So I can just go to my original equation. Y equals 2 times negative 3 squared plus 12 times negative 3 plus 10. So what is my y value when my x's are negative 3? Y equals negative 3 squared is 9 times 2 is 18. 12 times negative 3 is negative 36 plus 10. So my y value equals 18 plus 10 is 28. Subtract 36 is negative 8. So my vertex is at negative 3 and negative 8. So negative 3 going down, 1, 2, 3, 4, 5, 6, 7, 8. This is where my vertex would be. I know it's opening up because my a value at the start of the question is a positive, so my quadratic will be opening up. I go through those points like so. When the question says state the domain and range, so domain again is all the x values covered in this question. So it's forever going left and right. We can't see that, but it will be because we aren't given any restrictions. So our domain is x is an element of the real numbers. It's going to cover everything. My range always has limitations with parabolas because we either have a max or a min value. So if it's opening up, I have a minimum value of my y is negative 8. So y is greater than or equal to negative 8. Example 2. Sketch the graph of f of x equals negative x squared minus 3x plus 12 and state the domain and range. So when we have a negative in front of our x, it's easier for us to work with if we have a positive value there. So if you ever have a negative value, I would recommend factoring out your negative first. So not that you have to, but it makes your life easier if you factor out that negative and then rewrite your equation with opposite signs. Then you can factor your trinomials as normally as you would have. So there's no GCF here. I can't factor one term out of everything besides that negative sign. So I have f of x equals negative something that would multiply to negative 12 and add to 3. So my factors of 12 are 12 and 1, 6 and 2, and 4 and 3. And there's no possible combination of those 6 factors that would either multiply to negative 12 and add to 3 as well. So this is where we can use partial factoring. So partial factoring allows us to factor our x's out of the first 2 terms and leave our 12 as it is. So if I were to factor out from x squared and 3x, I can factor out an x. I'm left with x plus 3. And then my 12 at the end is just still there. Subtract 12. So then we look at our variables. If we're looking for our intercepts again, that's when y equals 0. So when would these variables be 0? What would negative x have to be 0? And what would x plus 3 have to be 0? So if x here equals 0, that would make that equal 0. Or if x equals negative 3 in the second term, that would also make that equal 0. So to identify what our y values will be at those points, we can plug in our x equals 0 and our x equals negative 3 into the original. So f of 0 is negative 0 squared, subtract 3 times 0 plus 12. What's my y value when my x value is 0? 0 squared, subtract 3 times 0 is 0 plus 12. So when my x is 0, my y value is 12. Now when I plug in my negative 3, negative 3 squared, subtract 3 times negative 3 plus 12, I will have negative 3 squared is 9, but with a negative sign in front, so negative 9. Negative 3 times negative 3 is a positive 9 plus 12. So those will cancel each other, and I'm left with 12 again. So I will have a point of negative 3 and 12 and 0 and 12. So these are not our intercepts because we couldn't factor that, and we haven't learned a strategy to factor that yet. So we're just using our partial factoring to determine 2 x values that have the same y. 2 x values that have the same y, yes. So negative 3 and 12 and 0 and 12. 0 and 12, negative 3 and 12. So then to determine where our vertex is, it's going to be right in between negative 3 and 0. So we would add that up. I'll use a different color. Negative 3 plus 0 divided by 2. It's going to be negative 3 over 2, or negative 1/2. 1.5, sorry. Negative 1.5 is going to be our axis of symmetry. So 1.5 would be about here. So now we want to determine what's our y value when my x is negative 1.5. So I'm going to erase a little bit of our work up top here. What is my y if x is negative 1.5 squared? Subtract 3 times negative 1.5 plus 12. You can use your calculator for that as needed. And you will get it's 14.25. So 14 1/4 up here will be about right here. We can see by the shape if that's our max point that our graph is opening down, which we also know because our a value is a negative from the original question. So it's just a matter of connecting your points there. So we do know that it's going to be continuous graph and will intersect our x-axis at some point. But because we haven't learned how to factor something that doesn't factor easily and have an obvious 2 points, we want to factor partially, and that way we can just find two x values that share the same y and identify our axis of symmetry that way.